Hello everyone. Welcome back to the daily questions. Today we going to show harder versions of the of yesterday problem. That it largest unequal adjacent groups subsequences two. Okay, this is classified as a medium problem. The statement is the same as the previous, but have a little change in the conditions we need to follow here is we need to find the largest subsequences. That's the Hammond distance between two adjacent element in the selected subsequences is one. That's it. The that's the absolute difference of that is difference between the two adjacent element is one, exactly one. That's it. Maybe like 2 with 3, the difference is 1, or 2 with 1, the difference is also 1. Yes, the statement also said us to return the selected subsequences at the easy versions. Okay, let's take example 2. ABCD, we have groups 1, 2, 3, 4, so we can select on this because the difference between the two adjacent elements is 1. Wait. The constraints here is 1000 for the words and the groups length. And the value of groups is from extend from previous. The easy version is 10 10, and now is from 1 to n. That's 1000. So we can use the same approach at the easy version because the previous version is only have the groups of 1 and 0. That's the alternating. So we only need to choose it alternatively. But in this problem it's harder because if we choose alternatively it might not optimal. But let me take an example like 3 2 like for this you can choose 3, then choose 2, then choose 4, then you must choose 5 or 3 again. So let's consider this, and we have insert some element like this 2. You can choose this like 2 1 and 2 like this. If you start by choosing 3, you might choose 4, and then you must choose 5 because there no way. Then you have the result of length of e5 e4 3. But if you choose 3 and ignore this, you choose 2, and then you can choose 1 and then choose 2 is length 4. So now today's problem is not an easy choosing alternatively 1 0 1 0 1 0, but now we need to take care and manage small state. The state of the previous number you have choose to make sure the Hammond distance. The Hammond distance is 1. That's it. The difference of the graph like minus 1. Period graph with the Q1 graph is 1. Now, okay. Now we will dive focus into the solutions. As you can see that the length is 1000. You can think about solution like dynamic programming, and you can see that this problem has 2 conditions. First, we need to choose element that's the groups e different from cheese equal exactly equal to 1, and we need to find the math length of the set. So if it look really like the largest longest increasing subsequence. That's it. The longest increasing subsequences. The condition we need to hold here is also select the maximum length of selected n, and it must be like this e, right? With g e is same as this. The difference between the longer LIS and this problem is the conditions here is different. You can search on Google this problem. This is a typical classic dynamic programming. Is to choose a subsequence in an array that increase is strictly increase. Like this, we're gonna choose 10. This is the length of 6. Okay, so if you don't know it, keep following me. So we need to use dynamic program here because we need to manage state that DPE is the maximum length of selected subsequences from 0 to E. From 0 to E, that is the first E element. Not for E, it must be E plus 1, right? Because we are using a zero index array element. So we need to find the pivot state. That is, the TPE we have to the mass of on possible state. That we come from Z. That's Z must be less than E, right? The come from pivot state, like you can take example 2, you can this see this 3. Let ignore this. We need to focus on the groups. Like if you add the 3 at the third index, so you can choose the pivots. You can select pivots index at this 2 or 1, whatever. That is from 0 to less than E. Okay, it must be like this. You can choose Z from the pivot position any, but you must keep this condition satisfied. That is, the difference between groups E and group C is exactly 1. Okay, so our solution is just try on the possible way. Okay, now let's dive into the implementation. Plus 1. Okay, plus 1 means we choose E. We choose each element to append to the last of the previous chooses subsequence. Okay, let's create db or sign and we also need to trace the answer. So we need to store the trace like at E. What is the previous selected position? That is trace E equal to Z. Trace E equal to Z. That's append E element to. So we assume that trace equal to 0 if equal to -1 is mean we have no previous position. That's the beginning of the subsequence. So let's do that here. Or sign dp is equal to 1. Why? Because we can choose itself. Yes, a single element is also a valid 1. So the minimum able is 1. That is choose itself. So look from 0 to E. Choose on the possible way. F absolute graph E and graph C is exactly 1, and this is the more optimal way. That's it, dip E less than the dip Z plus 1, because we need to find the mass, okay? And trace EEZ, previous of EJ, previous of EJ. Sorry, I forgot that I here. This character is I, not E. It's my Vietnamese. Right. It's done. It's already done. But we need to store the position of the answers. Like if dp mass length part, we need to store the position at the end position of the optimal subsequence is less than dpe. So we found the new end position. Okay. Sorry. E. Now we have done. Now all we need to trace the answers. We want to trace because we have the trace reverse from back to front. So gonna we trace from the back. We gonna receive the reverse array bit. That's the solution. Y pause. That's the or you can write like this, different from -1. If it's not n, it's not the beginning of the subsequences. Keep tracing. Using trace to back to zoom. We zoom to previous position. Don't forget to add the answers. Was curve pause. So we have the reverse array, so we need to reverse it again. Check it out. A simple make a type of mistake. Let's see. Oh. Okay. Wait a minute. One, two. This must be. Okay. Y expected is. Oh, maybe some mistakes in my expected Y. The Hammond distance between sorry that we have another condition here is the length equal it's my mistake. I didn't read the statement carefully. I forgot it. Yeah. I forgot it. Oh, it's equal length and Hammond distance. The Hammond distance are different. I mean the Hammond distance between, that means the distance, Hammond distance, not oh my god, it's my third mistake from the beginning of the step. Okay, so the condition is not only the same length, was C and was C, and also this is not the Hammond distance. The Hammond distance here. That's why I misunderstood. Sorry, really sorry, because where your times was E and was C is 1, so we need to implement the Hammond distance here. the Hamming distance is the different character between two equal string, like this. Can't. This and Hamming distance between was A and was C is 1. Why the output? What? Two. Oh. Equal to 1 was C and was D. What is the difference for size? The Hamming distance. What's wrong with my implementation? We forgot the diff groups E different from group C. Too many mistakes today. I lost my skill of reading statement. Okay, I got upset. And the last condition is different from G. Okay, it passed. Okay, you can optimize using another technique, but I'm gonna use an optimal here if like greater than 1, so we can return skip a simple optimal. I hope it's past just a little bit. Okay, so that is solution today. You can optimize this using some technique, but it's a hard version. So let's stop here. Have a nice day.